Welcome students, I am Adlin, lecturer of Universal College of Pharmacy. Today topic is capillary electrophoresis. Uh, Previously we see the introduction of electrophoresis, next types, next the paper electrophoresis and gel electrophoresis is already we see. This day we see about the capillary electrophoresis. First, the definitions of capillary electrophoresis means this is similar to the gel electrophoresis technique. Capillary is filled with an polymer solution composed of either agarose or polyacrylamide that create the molecular sieve. The molecular sieve so formed is known as replaceable physical gel. The mixture of sunlight, when allowed to flow through the sieve, gets separated depending upon their mass to charge ratio. Used to separation of micromolecules which bear similar charges but differ in their size. These kind of separations are facilitated by the use of high voltage, which may generate electroosmotic and electrophoretic flow of buffer solution and ionic species respectively within the capillary. That is called the capillary electrophoresis. Next we see the principle of the capillary electrophoresis. Capillary electrophoresis is an analytical technique that separates ions based on their electrophoretic mobility with the use of an applied voltage. The electrophoretic mobility is dependent upon the charge of the molecule, the viscosity and the atom radius. The rate at which the particle moves is directly proportional to the applied electric field. The greater the field strength, the faster the mobility, and vice versa we done. This is the principles of capillary electrophoresis. Next, the theory we see about theory of capillary electrophoresis. One of the theory, the electroosmotic flow, EOF, it means electroosmotic flow due to usage of high electric field. Osmosis may occur. Osmosis may high concentration, low concentration movements. The speed of electroosmotic flow can be adjusted by changing the buffer pH. The speed is adjusted by changing the buffer pH. The bulk movement of solute occurs because of electroosmotic flow. Electroosmotic flow is sufficient to sweep all the neutral molecules. This is the theory of electroosmotic flow. This is the structure of capillary electrophoresis. In capillary electrophoresis, many components we use. First one buffer, sample, capillary, detector, computer, power supply, anode, cathode. These are the components we used in the parts we used in capillary electrophoresis. Next we see the modes of capillary electrophoresis. There are 4 modes. They are capillary zone electrophoresis, C is a T, capillary, second one capillary gel electrophoresis, CGE, third one capillary isoelectric focusing, CIEF, fourth one capillary isotachophoresis, CITP. These are the 4 modes of capillary electrophoresis. First one, capillary zone electrophoresis. It analytes move in the electroosmotic flow but separate into bands because of difference in their electrophoretic mobility. This is the capillary zone electrophoresis is a structure. Second one, capillary gel electrophoresis. It is adaptation of traditional gel electrophoresis into the capillary. It uses separations based on the difference in solid size as the particle migrate through the gel. Gels prevent the capillary walls from absorbing the solute. It uses a high voltage power supply to anode and cathode. Uh, Traditional gel electrophoresis. This is known as the capillary gel electrophoresis. Third one, capillary isoelectric focusing technique commonly used to separate peptides and protein. These molecules are called future ionic compounds. So each molecule has a specific isoelectric points. So if pH is equal to pi means isoelectric point, then molecule became a neutral. So these molecules called future ionic compounds. It is used to separate peptides and proteins. This is known as the capillary isoelectric focusing. Last modes, capillary isotachophoresis, CITP. It is a focusing technique based on the separations of sample components between leading and terminating electrolytes. Next one, components of capillary electrophoresis. First one, reservoirs, electrical buffers. Third, power source. Fourth, capillary tube. Fifth, detector and computer. Sixth, samples applicator. Reservoir, electrical buffer, power source, capillary tube, detector and computer, sample applicator. These are the components we used in the capillary electrophoresis. This is the structure of capillary electrophoresis. In structure, what are the parts included means capillary inlet, anode, cathode, reservoirs, two reservoirs, buffers, high voltage, capillary tube, detector, and computer. Next we see the procedure of capillary electrophoresis. This one the structure. High voltage power is used. Procedure. First point, fill the tube with a sample solution. The capillary tube filled with a sample solution. Carry out the sample application by high voltage injection or with a pressure injection. High voltage is conductor. Apply high voltage of 20 kV. Two forces acting on the protein. The attraction of the first negatively charged proton towards the positive electron anode, and second the electroosmotic force. First one attractive force, second two forces will act on the protein. Fifth point, electroosmotic drugs all the molecules towards the cathode irrespective of the charges. Sixth point, during this migration positively charged molecules move faster than negatively charged one. The detection of resolved molecules is done a UV monitor, and the signal is recording in a recorder. This one is the sixth step. Seventh point, a capillary electrophotogram can obtain by plotting the signal against time. This is the procedure of capillary electrophoresis. There are 7 steps in the procedure capillary electrophoresis. Next we see the factors affecting electrophoresis. What are the factors affected by the capillary electrophoresis? First one, sample. Sample size, charge, shape affect the capillary electrophoresis. Second factor, electric field. High voltage field is used. In that also affect the electrophoresis. That are voltage, current, resistance, electric field affect the capillary electrophoresis. Third one, buffer composition, ionic pH, that also affect buffer affect the capillary electrophoresis. Next, last one, supporting medium. In the supporting medium, capillary, that capillary adsorption, electroendoosmosis, molecular sieving, that supporting medium and capillary, that is affected the capillary electrophoresis. These are the factors affecting the electrophoresis. Next we see the advantages of capillary electrophoresis. First one, new selectivity, easy and predictable selectivity, high separation efficiency. Fourth one, small sample required. Fifth, fast separation done. can be automated. Last one, easy coupled to MS. These are the advantages. Other advantages are high cost. Low cost. These are the advantages of the capillary electrophoresis. Next, we see the disadvantages of capillary electrophoresis. First one, cannot do preparative scale separations. Low concentration, and last one, large volume defects. These are the advantages of capillary electrophoresis. Last, we see the applications of electrophoresis. Capillary electrophoresis. First one, used to separate amino acids. Second one, used to separate peptides. And third one, used to separate protein. Fourth, used to separate DNA fragments. Fifth, it is used to separate nucleic acids. And last, used to separate drugs, even metals also. These are separate by using the capillary electrophoresis. Applications others, genetic analysis we use, pharmaceuticals we analyze of use, pharmaceutical with chiral centers, enantiomas we use, counter analysis in drug discovery, protein characterization. Other uses, it is used for the isolations of lipoprotein in serum and enzyme in blood. And the capillary electrophoresis is also used for analyzing the purity of oligonucleotides and RNA, as impure oligonucleotide can interfere with a hybridization reaction. The technique offers adequate accuracy and precision and is of immense help in the development of nucleic acid based therapeutic agents. Other use, electrophoresis has been used for fractionating low molecular weight compounds like amino acids, vitamins, nucleic acid, antibiotics, alkaloids, carbohydrates, etc. It is used as a diagnostic tool for diagnosing hereditary anemias, as it helps to detect the presence of abnormal hemoglobin in blood, that also detected by using the capillary electrophoresis. Gel electrophoresis is used for sequencing DNA to determine encoded genetic codes. These are the applications of capillary electrophoresis. Today we discuss many that is capillary electrophoresis. First we see the introduction, principle, modes of capillary electrophoresis. There are four modes: capillary zone electrophoresis, capillary gel electrophoresis, capillary isoelectric focusing, capillary isotechophoresis. That also see. Next we see the components of capillary electrophoresis. Next we see the procedure of capillary electrophoresis. They have 7 steps. Next we see the factors affecting electrophoresis. There are 4 factors: sample, electric field, buffer, supporting sample, charge, size, shape, electric field, voltage, current, resistance, buffer, composition, ionic pH, supporting medium, adsorption, endosmosis, molecular chemistry. That also affect the capillary electrophoresis. Next we see the advantages and disadvantages of capillary electrophoresis. Advantages can be automated, easily coupled to MS, fast separations, small sample record, high separation efficacy, and easy and predictable selectivity. Disadvantages, next see, cannot be prepared to scale separations, low concentration, and large volume defects. Next we see the application. Main application is used to separate amino acid, peptide, protein, DNA fragments, nucleic acid, drugs. These are see today. Thank you.